We live on an incredibly gifted planet, a planet where many factors came together to make life possible. And not only simple life like bacteria and viruses, also birds, whales, humans, and whole interconnected ecosystems. These life-giving factors include the appropriate distance from the sun, the presence of liquid water, and very importantly, the right temperature. It has been known for 200 years that the atmosphere plays an important role in regulating the Earth's temperature. In 1824, Joseph Fourier was the first person to study the Earth's temperature from a mathematical perspective. Fourier calculated that our planet would be much colder than it is if the incoming radiation from the sun were the only warming effect. This led him to deduce that the atmosphere added heat, similar to the glass in a greenhouse. In 1856, Eunice Newton Foote was the first to publish a paper that showed that CO2 had a warming effect on the atmosphere. The title of her work was Circumstances Affecting the Heat of the Sun's Rays. Interestingly, she wrote, an atmosphere of that gas would give to our Earth a high temperature. And if, as some suppose, at one period of its history the air had mixed with a larger proportion than at present, an increased temperature must have necessarily resulted. In 1860, John Tyndall, based on Fourier's work, discovered that CO2 and water vapor were the main gases responsible for regulating the Earth's temperature. He inferred that these gases have the ability to absorb the heat energy emitted by the Earth after being heated by the sun's radiation. Hence, they are called greenhouse gases. His measuring device, which used thermopile technology, is an early landmark in the history of absorption spectroscopy of gases. He was the first to correctly measure the relative infrared absorptive powers of water vapor, carbon dioxide, ozone, and methane. Later, in 1896, Swiss scientist Svante Arrhenius, using a mathematical model, was the first to demonstrate that increasing CO2 in the atmosphere would increase global temperature. In 1903, he received the Nobel Prize in Chemistry. The current levels of CO2 are at about 428 parts per million. That translates to about 0.04%, a small quantity. However, these scientific studies demonstrate that CO2 in small quantities and with small changes can significantly alter the Earth's temperature. In fact, without greenhouse gases, our planet's average temperature would be around 19 degrees Celsius below zero. That's about minus 2 degrees Fahrenheit. And the Earth would be completely covered in ice, a condition that would not allow life as we know it to exist. CO2 and other gases in our atmosphere add enough energy to maintain an average temperature of about 15 degrees Celsius. That's about 60 degrees Fahrenheit. So even with a small amount, the greenhouse gases are adding a lot of thermal energy to our planet and making life possible. We can use the Stefan Boltzmann law to give us an idea of just how much energy or heat is added by the greenhouse gases in our atmosphere. This law describes the relationship between the temperature of an object and the total amount of energy it emits per unit area per time, where I is the energy emitted per unit area per time, measured in watts per meter squared. Sigma is the Stefan Boltzmann constant, and T is the absolute temperature in degrees Kelvin. Using this equation, if we plug in the energy emitted per unit time, or the net energy our Earth receives from the sun, into I, and plug in the Stefan Boltzmann constant and solve for temperature T, then we have that the Earth, with its distance from the sun, and without greenhouse gases would have a temperature of minus 19 degrees Celsius. And if we consider the average temperature of our planet to be about 15 degrees Celsius, the difference is more than 30 degrees C. That means that our atmosphere adds 150 watts per meter square of energy. That's a lot of energy. And it's all being added by the greenhouse gases in our atmosphere. An analogy would be that our atmosphere acts like a blanket covering our planet. If you make the blanket thicker, then less heat will escape back into space. Our equation gives us an idea of how much energy that greenhouse gas blanket is adding to our planet. Other studies on historical CO2 fluctuations in our atmosphere confirm the close relationship between greenhouse gases and temperature. Based on the analysis of air trapped in ice cores at the poles, it has been possible to measure CO2 concentrations over thousands of years. Based on other geological and paleobotanical studies, it is known that CO2 has regulated the Earth's temperature for millions of years. The climate system functions as a result of energy. The sun's energy is required for water evaporation, cloud formation, and air circulation. Since the beginning of the industrial era, we have been adding millions of tons of CO2 to our atmosphere each year, modifying chemical and physical factors and altering our planet's thermal balance. This increase in energy stored in our atmosphere is modifying our climate. In fact, we have modified all the elements that define climate, going all the way from temperature to precipitation and wind patterns. Each year, we are adding a tremendous amount of energy to our climate system. This additional energy is causing hurricanes to be more destructive, causing the most destructive Category 5 hurricanes to occur earlier in the hurricane season, as we have witnessed lately in the Caribbean. The increase in atmospheric energy is causing more severe and prolonged droughts, as has happened in the western United States, southern Europe, and the Somali Peninsula in Africa. At the same time, rainfall is occurring far above normal, causing flooding, destruction of roads and homes, and the loss of life, as we just saw in Texas. Another example is the tremendous flooding that occurred on the east coast of Spain in the Valencia region, causing at least 219 deaths and millions of euros in damage. Climate change has also favored the outbreak of devastating wildfires, such as the one that devastated Los Angeles this year. In all these events, the comments repeat themselves over and over again. That is, we've never experienced anything like this before. We have never seen this amount of rain, or the destructive force of the wind, or these extreme temperatures. There is a definite trend that we see repeating itself around the world, a trend that is telling us that the climate is becoming more extreme. But without a doubt, the strongest sign that the climate is changing is the continued rise in temperature. Recent data, including record temperatures in 2023 and 2024, indicate we are rapidly approaching, if not already consistently exceeding, the 1.5 degrees Celsius global limit agreed upon in Paris in 2015. Surpassing this mark permanently puts the world on a dangerous path towards severe climate extremes. As history shows us, the knowledge of the role of CO2 in regulating our planet's temperature is not new. It has been around for more than 200 years. Science confirms that climate change is real, that it is a result of human activity, and that it is getting worse year by year. Ignoring this and doing nothing about it is very dangerous. Continuing with the same fossil fuel-based lifestyle means continuing to increase the thermal energy in our atmosphere and dangerously overloading our climate system. Governments that choose to ignore climate change will jeopardize their citizens' well-being as they cease to invest in vital research and development for adaptation and mitigation. causing the country to dangerously fall behind in critical knowledge about the changing climate, resulting in a lack of preparedness for future climate challenges.